Hello guys, this is Razor Game Dev, and welcome to the second episode in Let's Make an Adventure Game in Love2D. So today, my plan is to finish up on the entity component system. Probably not finish it up, but at least get it usable. And also explore some options in how we're actually going to display the game. And actually, starting off, I'm going to talk about that right now. So the game, okay, so I'm really inspired by the Zelda games that were on the original Game Boy Color, and I kind of want to have my game snap to pixel. Now, I don't know if there's a good way to explain it without actually just showing you what that means, so we're just going to create a canvas. Now, a canvas in Love2D is basically, if you guys know about rendering to a texture, and then drawing the texture in OpenGL or something like an FBO, well, that's exactly what it is in Love2D. Basically, just rendering to a canvas. So I'm going to say canvas is equal love2graphics.new canvas. Now the just a second. There we go. So now the size of the canvas. For right now, I'm just gonna make it the size of the actual Game Boy Color screen. Now that's really limiting because that's how big we're gonna have to draw to it, which means everything has to be really small. Now, in the future, if we make this dynamic enough, we should be able to change it to whatever we want. But for right now, we're gonna try to keep this a little bit more authentic. So I think it was 160 by 144, if I remember correctly. And then one thing I want to do up here is say game.canvas set filter, because I want to turn this into nearest neighbor filtering. That just means it'll be pixelated if it upscales or downscales. Now right now that doesn't do anything. We still have our old project right here. Yep, it's right here. Nothing changed. But what I want to do is actually draw to the canvas. So how do we do that? Well, we have to say love.graphics.setCanvas, and then here's where we put in the canvas that we want to draw to. So I'm going to say game.canvas, and then right here we want to unset the canvas. That just means stop drawing to the canvas and actually draw to the screen. And then now I'm going to actually draw the canvas. So in between here, whatever draw call we actually have, it's not going to draw it to the screen, it's going to draw it to our game.canvas. Think of it like a piece of paper that we draw to instead of to the screen. And then we're going to actually draw that piece of paper to the screen right here. So love.graphics.draw game.canvas. Then we're going to draw it at coordinate 0, 0. Alright, again, nothing's going to change. So let's actually try drawing something to this canvas. So let's say love.graphics.circle. Believe it needs to be, I think you can set fill right there. 0, 0, and then a radius of 32. Let's do that. Yeah, okay. So I did that wrong. I don't think... Can you do that? I might Google it, we'll see. No, I think you have to. Yeah, okay, gotcha. Let's move this to like 16. How about 32. Alright, anyway, it's not important. Anyway, we're drawing to a circle. And that looks like normal, except if we comment this out, you'll see that nothing draws. Because right now we're just drawing to the canvas and nothing else. Now, you'll notice that the canvas is really small right now. If we actually draw a rectangle, let's do this. Let's draw a rectangle to the canvas. That's the size of the canvas. So let's set the color to like an orange or something. Let's do 200, 0, then love.graphics.rectangle. Let's fill it. We're going to say 0, 0, and then canvas game.canvas get width, and then game.canvas get height. That's how you get the width and the height of the canvas, and that should draw a rectangle. Now let's reset the color. Set color, set color 0, 0, 0. Or actually, let's do 255, 255, 255. So we draw a white circle. So what we're doing is we're filling the entire canvas with orange, basically just drawing a rectangle, orange, and then drawing a circle on top of that. And if we draw here, you can see that the canvas is definitely not the same size as the screen. Now it seems like the origin's at the center, which is kind of strange, honestly. Well, anyway, so let's actually scale up the game to be the right scale. So right now, the actual scale of the game would be let's think. It'd be love.graphics.getWidth divided by game.canvas.getHeight, or width rather. What that does is just it says how it's how scaled down is the canvas. So if we print this, I believe I might have gotten that wrong. Yeah, so the canvas is actually 5 times smaller than the width of the screen. The width of the canvas is 5 times smaller. So to scale it up, all we have to do is say rotation 0 and then scale. And then scale again. If we build that, it fills the entire screen. And as you can see, the circle is actually pixelated, which you wouldn't expect it to be pixelated, because if we turn this up to like 800 by 480, which is I believe the size of the game, you'll see that it's actually smaller now and it's not pixelated. So this is how we can do nice pixelated graphics that actually snap to the screen. Actually, let's test this out. Or snap to the pixel. X is equal to, let's see. Let's just say X plus dt times 10. So this is going to move the circle. Nope, it's not, because we need to actually set this at X. So as you can see, the circle is snapping to a pixel. And this is really, this is a lot like how it would work on a Game Boy and stuff. There's no like quarter pixel, there's no half pixel, it's actually at the pixels X and Y, which is kind of cool. So I think we're going to keep that. Now, instead of doing this, we're going to actually we're going to move the game.render inside the canvas there. So everything that happens within here, it's going to be on the canvas. And now if we build, everything's the same, except this is actually pixelated. And let's go to the level. Oh, built it again. I just came from Visual Studio, so my hotkeys are going to be a little bit messy. Let's see. 0, let's scale it up to 3 times. Let's go to main. Ooh, that looks horrible. Okay, I guess you can't do that. I might be yeah, there's probably a font size. Yeah, okay, so that's not how it works from here, but anyway. Anyway, so sweet. So in the level, we're creating a player. It looks like I was creating a player in the main. Yeah, we are. So a new player. We're doing that every time we render. That's weird. Let's go with scene. Sorry, just doing some boilerplate. OV init. Ooh, this is really old code then. All right. OV init. Let's just make sure this is getting called the render right here. So let's say love.graphics circle fill. Actually, let's do line just for the heck of it. 120. Nah, let's do 64. Radius of 16. Build. Go to the main, then build. So yeah, that's drawing a circle right there. Looks like we have some issues because it's not actually... Oh, okay, so we got rid of the scale for some reason. Let's... Where's the scale? Okay, so we need to keep the scale. That's one thing that bugs me about Lua, is that it's not... null values will actually... Like, if you didn't declare the variable scale, it just sets this to null, which means this would actually build and it will work without giving you a warning. Anyway, there's a circle, and that's why our print was looking so crappy. Anyway, that's your circle. It looks pretty cool. I like it. Alright. Okay, so let's go check out our entity component system. Let's see. So we got to require, so we make sure we get all that. Do we have any components yet? No, we just have this. So let's make a component. We're just going to call it csprite.lua. Local. I'm going to split the screen. So let's see. View. I should really learn the shortcuts to this. Columns. Alt-Shift-2. Okay, sweet. Okay, so csprite's going to be over here. Component's going to be over here. We're going to say local csprite. Return csprite. And we're going to make a new right here. New is equal to function. End. Okay, so local csprite is equal to, let's require, actually, let's just do it right here. Require source / oh wait, I don't have a source, never mind. I usually put all my code in into a subdirectory called source, but I didn't in this project for some reason. dot new. Component takes an ID, which would be C, or let's just do sprite. And let's return this, just like that. So that shouldn't do anything. Let's see. Function C sprite dot load. That really should be an init, but whatever. Let's just say for IV. Let's do I pairs loop over the arguments and just print that. Arfs print v. Then let's print I and then v. Alright, so over in level, nope, actually over in main, let's move this over to level. And let's move this filter up because we don't want to go to the scene before we set the filter. Anyway, in level now, let's make sure we put that there, and let's print hey, just to make sure this is actually, whoa, what did I do there? Just to make sure that's actually being called. It is not. Hold up. What did it say? Okay, so acquiring scenes at level. Let's go to level. OV init. Let's go to scene. That is definitely overridable. Ah, gotcha. Not calling it right here. Let's build that. Okay, so we're calling it. We're creating the player. Hopefully, we're creating the player. Okay, so we have an entity. Now we can say, let's go into the entity over here. Let's see what we can do. We can add a component. So let's do that. E.add or :add. The component's gonna be require components /c sprite dot new. The arguments, we're just gonna say hello second, just to see which one's second, and then a number 128. Let's build that. Go into the main and then build that. Okay, attempt to index a Boolean value. Sprite number 3. Okay, let's go to component. Let's make sure we return the component. Okay, so yeah, we're printing the arguments. That's exactly what we want. Okay, sweet. So, okay, that froze for a while. That was weird. So now what we can do is what do we need to pass in? Now I want to pass in a type. So C-Sprite's a little bit. Let me move the screen down a little bit. A little bit of a bad name, just because we'll be able to render a rectangle instead of a sprite. But whatever, it's not a big deal. So we're gonna say if args.type is equal to rect, then else if args.type is equal to circle, then. And actually, before we do this, we're going to need a body component. So let's make a body. Because we want to know where to actually render the sprite. Let's remove that. Or rename it. Yeah, so let's just copy this. Copy, paste, save. Hopefully Sublime will recognize this as a Lua. Okay, there we go. Control D, Control D, Control D. C underscore body, and let's make sure we undercase this. C underscore body. Sorry, that was my girlfriend. Hold on. Okay. Anyway. It's like slowing down my whole computer, those notifications. Okay, so let's go back to here. Okay, so the body. The body doesn't need any of that. Let's just say variables that it needs is a position. And actually, oh man, there's a lot. Everything kind of revolves around itself. Let's create a new thing in tools. Let's call it math2.lua. And I'm back. So what I'm going to do is I'm going to create a new math module. So I'm going to say vec2, math.vec2 is equal to a table. And I'll make a new is equal to function x comma y. Now vector is, if you're from a C++ background, then it's nothing like a vector in C++. A vector is just if you remember back in math, it's a point and then a direction. Or in this case, just a point in x and y coordinates. So that's all we're going to make. So local vec is equal to a table. And I'm naming it a vector 2 because in the future we might want to make a vector 3, which is used for 3D math. So vec2.x, I'm going to capitalize that, is equal to x or 0. Actually, let's not. Okay. Vec2.y is equal to y or 0. So that's just saying make it equal to the arguments or the number 0 if the arguments are null. Function vec2 add vec2, or let's just say v. Come on now. Self.x is equal to self.x plus v.x. Self.y is equal to self y plus v dot y. Just like that. Function, if you do vec2 multiply, these are the more important ones. I don't find myself using subtraction or division too much. Well, maybe division. If we need them, we'll implement them. Right now, we're just going to make the necessities, basically. V dot y. Perfect. Okay, and then another one I'm going to add is a set. Set, and then n. Self.x is equal to n. Self.y is equal to n. Another thing I'm going to add up here is 0. Okay, so this is just going to create a 0 vector, which is just going to be a vector with zeros. It's pretty straightforward. So local v is equal to math.vector. So we're just going to create a vector, new, and say 0, 0, and then return v. Actually, we don't really need to do this. It's kind of redundant, huh? Yeah, it's stupid because we just create a new one without any parameters, and I'll do it. Anyway, I'm coming from I've been using a ton of monogame in C#, which usually do this. Have a 0 for their vector. Anyway, let's go back to body. I'm going to say position. Let's require that new math2 library. So it's going to be in tools, math2, just like that. Let me check the time. We're doing good. 18 minutes. Okay, so position is equal to math.vec2.new, and we're just going to leave it blank. We're going to make an args.x, args.y, just like that. Then e.size is equal to math.vec2.new, args.width, args.height. So if we don't actually pass in an x or a y or a width or a height, it'll just default that to null. And all this is doing is it's attaching properties to the variable e. Okay. We might want to intersect function. We can do that right here, actually. Let's just do that real quick. All it's going to say is if another entity intersects with this entity, if e, let's say self. Actually, screw that. We're just going to do this. I don't know why I was doing it so dumbly. Also been working in JavaScript. Okay. E2, sure. If e2.position is equal to null, nil, return false. And else, or let's just say return e.position.x plus e, or let's say self rather, self.position.x plus self.size.x is greater than e2.position.x, and self.position.x is less than e2.position.x plus e2.position or size.x, and let's copy this and do the same for y. Just like that, change it to y. So what that's going to do is that's going to check if, just think of the width and the position as a rectangle. That's going to check if the rectangle is going to intersect with the other rectangle. That's usually a pretty useful function. We don't need this right here, by the way. That's a very useful function. Okay, so in here, I want to say, let's save, E, entity. You know, I just realized it's going to be very slow. I kind of want to push all the requirements onto a stack, and then when the, actually, sorry, my hands are in the camera, and then when the entity is actually loaded, then loop through the requirements and check it. So right now we're not going to work on the check, or the requirements, so I'm going to say, to do, Dustin, because that's my real name, please add a better requirement system using a stack of requires. Sure, whatever, that works. Okay, anyway, let's go over to level. Let's make sure we add that body component to the player right here. So let's make sure we add it before the sprite, because that is needed. And then in the x, y with height. So x we're going to say 0, y we're going to say 0, because we're going to spot in the 0, 0. Coordinate width is going to be 32, sure. Height is going to be equal to 32. Let's build, make sure there's no errors. Oh goodness. I need to change that build file to work. Okay, body 12. Okay. There needs to be a then. Again, I keep messing that up. It's not too important. Okay, so that worked. Okay, so C sprite. Let's just open up body. Why not? So is equal to rect. Then we're going to say e.draw type. Since we want to make sure we capitalize this. Is equal to args.type. Sure. Okay, next we're going to say function C sprite. Actually, just go into component, make sure we have this, colon, or dot, render, E, and then that's it. Okay, so, I don't know why that's like that. Okay, so we're going to say love.graphics.rectangle. No, actually say if e.drawType is equal to rectangle, then or let's say, let's create a local variable up here. Let's localize our draw calls. Love.graphics, or let's say local rect. Go to love.graphics.rectangle. Okay, we're going to say rect. It's going to be fill. E.position.x, E.position.y, E.size.x, E.size.y. Alright. And my contacts are drawing out. Alright, so I would imagine we would have something here. Whew! Okay, let's go to level, let's see what's going on. Let's see if this is actually getting called. Oh, I know why. I know why. Obviously we need to, up here, say type equal to rect. Whew. Yeah, we're contacts. I have a really strong prescription, so they dry out and get kind of crazy really easily. Okay, let's print this. Okay, so it's not being called. Let's see why. Is it because we're not calling init? Or load, rather? World. Let's go to entity world. Let's make sure this is getting called. Okay, so that is getting called. Oh, we still haven't done that. Okay, so for I is equal to 0 or 1, so we need to loop through our components and actually render the components and update the components. So self.component, components, capital, do. Pretty easy. We're going to say self.component I.update self. Just pass in self, then delta time. I believe that's it. Let's go to component, make sure. Component tick self delta time. Perfect. Okay, let's do the same over here. And instead of that, we're going to say render. And, render. Okay. And then we're not going to pass in delta time in its build. Let's see if it works. I keep doing that. Have it. Okay, still nothing. Still nothing. Let's hit the entities actually rendering. It is. Okay. So I would assume that would be working. Let's print number of self components. Maybe it's not being added to the table correctly. I am gonna be very upset if I do that again. Okay, yeah, that's what's happening. So it's not adding to the table correctly. Let's go into entity, add, oh, okay. So this is gonna be a little bit slower than I thought it'd be. Actually, this needs to be a pairs loop. Because we made it a dictionary, or a hash map, we need to do this differently, I believe. A hash map, let's do, means it's indexed by a, by an object, and in this case, I made it indexed by a string. Because we said set ID, so component args ID, so we're adding a new index, I guess, of component ID, and we're setting equal to component.load. What? This just needs to be the component. And then we're going to say component dot load self args. Yeah, I wasn't really thinking very clearly when we were doing that. Table expected got nil yesterday, because I'm used to working in C# again, like I keep mentioning for the billionth time. I'm used to working in it, which I've built a pretty resilient entity component system in that, but it means I have to fundamentally change how I do it for Love2D, because it's different. And I'm not too worried about having these, using pairs loops and all that. Yeah, it's a little bit slower, but I doubt we're going to have more than 20 entities on the screen at once. And clearly we're not, entity 43, function tick. Does components use tick? They do. Man, this is why I need a standard way of doing all this crap. Okay. There we go, finally. We got a rectangle on the screen. It's a big rectangle, because I forgot that we're drawing to a very small canvas. So let's go to level, and it's shrink that to like 8 by 8. 8 by 8 would be probably the size of a tile. Let's build that. Yeah, that's a pretty good size. Alright, sweet. So where is it printing? Hey. Let's find that. There it is. Let's remove that. There's a little trick for you guys. Just search the term that you printed, and then you can get rid of it pretty fast. Anyway, so we're rendering the entity at that position, 0, 0. So we can actually move this to like 100. I'm definitely gonna fix it. Yep, there we go. Sweet. So our entity component system seems to be working pretty decently. And I think this is a pretty good place to end off, I think. Yeah, so okay, so let's just talk about what kind of stuff I'm gonna do in this project that I think will be kind of cool for you guys to learn. For one, I'm gonna be creating these tables. Right now, you can see that we have to add all these components to the entity every single time we want to create it. Normally, you would create like a function that would spawn a player, but I kind of want to do something a little bit more dynamic and actually create players and entities and stuff from a table that we would load up. That way we can actually generate entities by using a tool or something, which would be kind of cool. Next episode, I think we're going to work on map loading and rendering and stuff, and hopefully we'll do something very, very nice, and also be able to create entities from the tile map, which would be epic. Anyway, thanks for watching, guys. I hope you enjoyed. Stay tuned for the next one. It's just going to keep getting better and better as we go on. And yeah, see you in the next video. Peace out.